Hi coders! CS Time channel here, and this time we will talk about bubble sort. Let's begin! Bubble sort. Bubble sort is the simplest sorting algorithm that works by repeatedly swapping adjacent elements if they are in wrong order. Bubble sort traverses from left and compare the adjacent elements, and the higher one is placed at the right side. In this way, the largest element is moved to the rightmost end at first. This process is then continued to find the second largest and place it, and so on until the data is sorted. Let's see the example. This is our unsorted array that I visualize it like this. We have 5 elements, and each element placed in one index 0 up to 4. And here is the first pass visualization. So we will traverse the whole array from index 0 to index 4. So in the first pass, we start reading from the first index. So we compare the first index to the second index. If the first index is bigger, then we swap the position since we want it ascending order. Otherwise, they remain in the same position. So from this, here is the result. And then for the second one, we will start reading from the second index. We compare it to the third index. Then if the second index is bigger than the third index, we swap the position. Otherwise, they remain in the same position. So from this, here is the result. We keep on doing so until we reach the last element for the first pass. So again here, we start reading from the third index, compare it to the fourth index. And the same concept applied here, and here is the result. And again here, we start reading from the fourth index, compare it to the last index. The same concept applied, and here is the result. So at the end of this pass, the largest will be in the correct position. This is why we call it bubble sort, because after each pass, the next largest items bubbles up and moves to its correct position. And we need multiple passes to fully sort this array. Now let's see the second pass. In the second pass, we also start reading from the first element or the first index, and then we compare it to the second index. If it's bigger than the second index, we swap the position, otherwise remain in the same position. So here is the result. And then again, now we compare the second index to the third index. The same concept applied, and here is the result. We again start from the third index, compare it to the fourth index with the same concept applied, and here is the result. And then again, we read from the fourth index, compare it to the last index. The same concept applied, and here is the result. So at the end of this pass, the second largest will be in the correct position. As I mentioned previously, the next largest item bubbles up and moves to its correct position at the end of each pass. And then now we continue to the third pass. We also start reading from the first element, compare it to the second element, and here is the result. Again, we continue doing the same. We start reading from the second now, compare it to the third index, and then here is the result. And then we continue reading from the third, compare it to the fourth, and here is the result. And then again, we read from the fourth, compare it to the last, and here is the result. Now, all our numbers in the array has been sorted. Now let's see the pseudocode. Here is our unsorted array, and to know the length of this array, you can use r.length. It will give us value 5. From the explanation, we understand that we need multiple passes. In every pass, you always start from the first index or index 0. And then, in the first pass, you will compare index 0 to index 1. And then index 1 to index 2. and then index 2 to index 3, and then index 3 to index 4. At the end of this pass, the largest number will bubbles up and it will occupy this position, which is 9 in this case. And then we do multiple passes. For the second pass, again, we also start from this. We compare it to index 1, and then we compare it to index 2. We compare it to index 3. We compare it to index 4. And then at the end of this pass, the second largest number, which is 8 in our case, will bubbles up and will be here. Okay, and so on. So from this, we understand that we need nested loop. Here I use for loop. The outer loop function to repeat the sorting as number as the element. So we will start the loop from 0 to the length of the array. And then we need the inner loop that move from 0 to the end of the index. And then we will compare the first index, which is 8, compare it to 7. If it's 8 bigger than 7, we swap the position considering we want ascending order. So array y, compare it to array y plus 1. If it's bigger, then we swap the position. To swap this, we need another variable. Here I use temp. So I use temp to hold the value of array y. And then now I can use the array y to hold the value of array y plus 1. And then I can use the array y plus 1 to hold the value of array y that I already hold it in the temp. Okay, we will keep on doing so and until all numbers sorted. Once the numbers sorted, then we can display the result using the looping and we read from the beginning till end and display it. In Java, we use it system.out, but in pseudocode, you can simply write output or display. Now let's see back the pseudocode. There is a room to improve our pseudocode or to optimize our pseudocode. What if the number already sorted or half sorted? Why we have to keep on sorting? Then we can optimize our code. I use variable sorted and I declare it as Boolean. And then we initialize the Boolean as false here. If there is sorting, then we change the value of sorted to true. Once it's out from the inner loop, we check. If there is no sorting, then we quit from the inner loop and then we go back to the first outer loop. We continue doing so until all numbers sorted. Another room to improve the pseudocode is, as you can see here, that in every pass, the largest number bubbles up and moves to the correct position. In the second pass, also like that. In the third pass, also like that. Then why we have to keep on reading until end of the index? So to improve that, we can change the looping here in the inner loop by changing it to r.length minus x, which is this. So in the first pass, we minus it with 0 because we need to read it until end. In the second pass, we minus it with 1 as this will change to 1 because we don't need to read it up to the end of the index, but we just need to read it up to here and continue so until end. So the complete pseudocode, it will look like this. Here is the application in Java using Eclipse, and I prepared the code. So I just paste it here. Exactly like our pseudocode, here is our unsorted array that I declare it using integer. Every instruction I end it with semicolon. The same like in the pseudocode, I use the nested loop here using loop, for loop. The outer loop start moving from the first index until the last index. And the inner loop also start moving from the first index, which is index 0, up to the last index that has not yet been sorted. We talk about it in the pseudocode just now. And then we compare it, the first index to the second index. If the first index is bigger, since we want it ascending, then it has to swap. And When there is swapping, it means sorting is happened. So we change the value of sorted to true as part of our optimization. And then if there is no sorting, we quit from the inner loop. It will keep doing so until it's done. Once it's done, then our data already sorted. And to see the result, we just need to output the result, and we do looping to read it from the first index until the last. Now let's see the result. Here is our unsorted array, and here is the result.
If you learned something from this video, please subscribe and like for more videos. Thanks for watching!